let's do chapter 12.2, angle measurement worksheet. So first one, they just want to draw angles in the given measurement standard position. So remember, standard position, we're always going to start off with our first line at the 0 degrees. And then a positive angle you go up, negative angle you're going to go down. So we're starting here at 0. And then we want to go to 160. So we know the sides are 0, 90, 180, 270. And we go back around again, 360. So 160 is between 90 and 180. So it'll be right here-ish. Ooh, that's a bad line. It's not like that. Again, I don't really care where. Like, technically 160 is more closer to 180, but it doesn't matter. I just care about if we get the right quad. All we really care about is getting the right quadrant right now. So this would be 160. So sitting with this one, negative 90. Well, here's 0. It's negative, so we're going to go down instead of up. If you go down, it's be negative 90, negative 180. Well, done. There's my angle. 75. So 0, 90, 180. 75, so here's 90. We're going to go start here. And then here's 90, so we're less than that. And there's 75. Now remember, again, the key is just getting the right quadrant. After that, I really don't care. Now we're in radian mode. So remember, my trick to this is start here at 0. This side is pi. This will be pi over 2, 3 pi over 2, and 2 pi. So my trick to this is always the same, which is you work here, you look at, so that's 5 pi over 6. So we want to talk about all this in terms of 6. So since this is 1 pi, I'm going to write that as 6 pi over 6. Right, so that's 1 pi, also known as 6 pi over 6 if you rewrite it in terms of 6. So to get here, we have to be 6 over 6. We're at 5 pi, we're a little less, so we're in this quadrant. We're over here somewhere. That is a bad line. We're around there. So this is where 5 pi over 6 would be. So around there. 4 pi over 3, same idea. Let me erase this, it's going to get in my way. Here's 0, here's pi over 2, 3 pi over 2, and 2 pi. Now, all I really care about is the horizontal, is the x-axis. That's all that really matters to me. So 4 pi over 3, again, same trick, 3 over 3. Now we're going positive, we're going this way. So I would hit 3 over 3, I need to go to 4 pi over 3, so I gotta go a little bit further. So around here. That would be 4 pi over 3. Again, all we care about is the correct quadrant. The next one, negative pi over 3. Well, this is 0. Negative, we're going down, so it's be negative pi over 2. Negative pi. The trick was, anytime there's a 1 on top, it's in the first quadrant. So it would be here, but since we're going negative, it's actually in here. So that's the trick. Anytime it's negative, anytime there's a 1 on top, it's in the first quadrant. So negative pi over 3. Like that. Now we want to find the reference angle. Now remember, the reference angle is the angle between the x-axis and the terminal side. Terminal side is the side that's not, like the last side we draw. Like these are all the terminal sides. So this will be the reference angle. This will be the reference angle. This will be the reference angle. It's always positive because you're always going less than 90 degrees. You always go to the closest closest x-axis. So it should always be positive. Always an acute angle. So for the first one, negative 120. So I'm just going to draw it. Here's 0. Here's negative 180. Because remember, here's negative 90. Remember, it's negative, we're going down. So negative 20 between these two. Something like that. It's negative 120. But that's not the question. The question is, what's the reference angle? That's this guy. So how far is 180 from 120? That's 60 degrees. Now again, keep in mind the reference angle is always to the terminal side. It's always an acute angle. So some people want to go like this way and make it 120. Way too big. It's always a short thing, right? It's an acute angle. It's the smallest side to the x-axis. And it's always positive. 350. So we're going to do that one real quick. So here's 0. That's positive, so we're going up. Here's 90. Here's 180. Here's 270. Here will be 360. 60. 350 would be very close to that, right? We're going all the way around there. It'd be 350. That makes the acute angle. The reference angle, sorry, this guy. So my reference angle here, 360 and 350 would be 10 away. So 10. 210. So we're going all the way down to 210. So let's get rid of some of that to get my way. Now let's do 510. So again, we're gonna start at 0. There's a couple ways to do this problem. So we're gonna start at 0. Let's see. We gotta go all the way up to 510. So this would be 90. Positive going this way. This would be 180. I can do math. This would be 270. 360. Now, since that's where it stops, and we want to keep on going, I go to 510. You just add 90 to it to keep on going, right? We always add 90 to get around. So 360 plus 90 would be 450. 450 plus 90 would be 540. And I can keep on going, but 510 is where I want to get to. So where's 510 at? Between these two guys, between 450 and 540. So 510 would be in there somewhere. Again, I don't really care where, just on the correct quadrant. So really what we're doing is we're going around in a circle and then going a little bit further. Again, that's not required, but just to show you what's going on. And then what's the reference angle? Well, the distance from here to here. 540 minus 510 is 30. So that's my reference angle, 30 degrees. Now I said there's two ways to do that. Instead of drawing it like that, you can always just take it off the top. So you have 510. This is subtract off a coterminal angle. Subtract 360 to get to the proper range. Then you get this. So 150. So it's the exact same as drawing 150. Here's 180, here's 90, 150 be over here somewhere. So it'll be 30 degrees. Right, and that works because 150 and 510 are coterminal angles, which means they have the same reference angle. There's 360 apart. There's like a rotation apart. So the way it works. Now we get to the radian measure. Now you could draw these. You don't have to though. If I'm doing a reference angle with radian measure, pi over 4 automatically is 45 degrees. So that's the reference angle here, is 45 degrees. Pi over 6 is automatically going to be 30 degrees. And pi over 3 is automatically going to be 60 degrees. Those you should have memorized. Anytime it's over 4, it's 45. Anytime it's over 6, it's 30. Anytime it's over 3, it's 60. Part of the reason is that if you look at here, right, pi would go right there. 180 and pi are like equivalent in these terms. So it's like when you have pi over 3, it's like you have 180 over 3 in degree terms. And that gets you 60 degrees. That's where it comes from. If I did want to draw just a practice, so I'm going to do a real quick practice. Here's 0. Here's pi. Remember, we're going to do 4. We do it all over the denominator, common denominator. So 4 over 4. What would 5 pi over 4 be? Well, this is 4 over 4. You got to go a little past that. So 5 pi over 4. And then this one right here would be 45. If I was doing this one, this is over 6. So it'll be 0. Pi, remember my trick? You make that 6 over 6. So it's 1 pi. 6 over 6 is 1. Now, what does that mean? That means right here would be 1 less. 5 pi over 6. We haven't got to 6 over 6 yet. Over here would be 1 more. 7 pi over 6. I need to get to 11 pi, so what happens there? Well, you go around again. So this is 6 over 6. You go around again. You get another 6 over 6, which is 12 pi over 6. So 1 less would be 11 pi over 6. 1 more would have been 13 pi over 6. But all I want was 11 pi over 6. So we went like this. And the reference angle, again, since it's over 6, is automatically 30 degrees. And then pi over 3, there's no number on top. It's a 1 on top, so it's in quadrant 1. So here's 0. Here's pi over 2. Pi over 3 is less, right? A third of a pizza is smaller than a half a pizza. So pi over 3 is over here. So that'll be 60 degrees. So that's how you find reference angles and reference stuff like that. Now let's convert it. So we just want to convert things. Right, so I have 50 degrees, I want to convert it to radians. So I'm going to use this formula right there. So I have degrees I want to radians, just multiply by pi, add it to 180, and I get 50 pi over 180. Or if you want to reduce, 5 pi over 18. So that's 50 degrees in radians. 5 pi over 6, same idea. That's in radians. Actually, it's opposite idea. That's in radians. So I want to go to degrees. So I go this way, use this formula. Basically, want to get rid of the pi. That's the way I should remember it. I want to get rid of the pi. So pi's on the bottom, 180 on top. The pi's cancel out. I get 5 times 180 over 6. And I'm going to reduce this. I can actually reduce these easier. 18 divided by 6 is 30. 180 divided by 6 is 30 because 18 divided by 6 is 3 and there's a 0. So I get 150 degrees. Over here, same idea. I want to convert 330 to radian measure. So I think of it this way. It's that I don't have a pi and I want a pi. So I multiply by pi over 180. So you get 330 pi over 180. If you want to reduce, that's like that. And it does divide by 3, so that'll be like 11 over 6 if you want to divide by 3. I don't care if it's negative, it's the exact same thing. I have radians, I want degrees, so I want to get rid of that pi. So pi's on the bottom, 180 is on top. The pi's cancel out. I get negative 180 over 4, which would get me, if I divide that, should give me 45. So negative 45 degrees. So like that. So that's how you can convert from radians to degrees using the formulas. I don't like doing it most of the time. You should kind of just know by drawing it, but it is important to know, especially over here. So here's the formula we're going to give for arc length. Right, so these are given to you. Length of arc is L equals R times theta. Area of sector is area equals 1/2 pi r squared. But the important thing here is theta is in radians. So if we use these formulas that are given to you, you have to be in radians. So you have to know, generally have to know convert from degrees to radians. Right, so remember degrees to radians, you multiply by pi over 180. There's a different form for this if you want if you did give it 2 degrees, but I would not give this to you. If you're in degrees, the formula is, for the arc length is, let's say x over 360, that's your angle, times the perimeter, which is pi times diameter, 2 pi r. See, a lot of this gets taken up in the radian degree itself. So that's the formula for arc length in degrees. Basically, circumference times what portion of circumference you want. Then it goes to the thing for arc length. It's x over 360 times what portion of the area you want. So pi r squared. So stuff like that. Now let's find the arc length here. So arc length is this guy right here. So all we're going to do is use the formula. And again, the ones with radians will be provided for you. The ones with degrees will not be. So I just tend to use this and memorize how to convert it. So L equals R times theta. I just need two things. I need R and I need theta. Well, R is 5, theta is 3 pi over 7. So there you go. If it helps, that's pi over 5 over 1. So it'll be 15 pi over 7. And I'm more than fine with that. I know it here says round to nearest 10th. This is fine. Next question. A swing has a 165 degree angle of rotation. Draw the angle in center position. So this wants to draw it. So here's 0, here's 180. 165 would be between 90 and 180, so around here. Again, I don't really care where it is, just so you know the correct quadrant. All that really matters. So 165. Write the angle measurement in radians. So now they want me to convert it. So I want to go from, I'll do B right here, 165 degrees to radians. So remember, in this, I just think about it, like I don't have the pi for radians, so I need to get the pi, so put it on top, over 180. So I get 165 pi over 180. So there we go. I'll probably put that in decimals if I want to. If the chains of the swing are 600 feet long, what is the length of the arc that the swing makes? Round yards to the nearest 10. So it looks like what this is actually a C. What they're saying is, right, you have a kind of a swingish set here. This is 6.5 feet long. What is the arc length it makes? So they want to know what this guy is. Well, we know this is 165 or 165 pi over 180. So to find the arc length, it's just the formula, R times theta. So I'm gonna bring up a calculator and actually put this into the calculator because these are all like ugly. It's an application problem, plus they're all like ugly decimals. So R is 6.5. My theta is this, because remember it's in radians, so it's just that 165 pi divided by 180. So I get 18.786, and there's 10th, right? So 18.7. So approximately 18.7. So that's arc length in feet. Describe how the arc length would change if the lengths of the chains of the swing were doubled. So they're going to double this. So 6.5 times 2 would be 13. So now it would be 13 times the same angle. And that would get me, I think this doesn't double the answer, but we should probably double check. It's going to give me this guy, But now we're just in, well, that's, yeah, it's definitely just going to double the answer. Right, it goes from 6.5 to 13. Like, nothing else changes. You just times everything by 2. So you get this. The answer doubles. So in this case, the answer doubles. The arc length doubles. That was for D. Let's move on. Find the angle with the positive measure and angle with the negative measure that are coterminous with this angle. So remember, coterminal, all that means is plus or minus 360. I guess in radians, you don't have a 360 because I just saw the radians right here. That means plus or minus 2 pi, because that's what 360 is equivalent to. So with the first one, they want a positive coterminal angle to this. So I'm just going to get negative 50 and add 360 to it. I get 310. Done. So negative 50 and 310 are exactly the same angle. Well, that is actually a coterminal angle. A negative version, well, this is already negative, so just make it, let's make it more negative. Subtract 360. Go around, back again. So you get negative 410. So that's all it is. If you go like negative 50, here's 0, here's negative 90. Negative 50 over here somewhere. And they're saying if you go to 310, that should be the exact same angle. So 0, 180, 270, 360. Right, it's me between these two. So, right there again. These are all the same. One goes back, one goes forward, one goes back and then back again. I don't know why I did that. So we have that. So next one, same idea. Find a positive coterminal at 330. So I'm just going to add 360 to it. And get 690. Find a negative coterminal angle, just subtract 360. So I get negative 30. 7 pi over 4, same idea, but now with radians. So if you have 7 pi over 4, we're going to subtract 2 pi. Common denominator, 1 over 1. So that gives me 8 pi. So we're just doing fractions essentially. So 2 pi in this, in terms of pi over 4 is 8 pi, common denominator. So just subtracting fractions. So I get, I guess I did a negative one first. Sorry about that. So I get negative pi over 4. So I did a negative one first. Now let's do the positive one. Let's add 8 pi. So I get 15 pi over 4. So again, these are all equivalent reference angles. Essentially, 7 pi over 4 is the same thing as 15 pi over 4, same thing as 11 pi over 4. They're all about the same. Again, it depends because you're like going around in more circles, but they're all the same reference angle. So the next one, it's already negative. So to find the positive coterminal, we're just going to add 360. Actually, sorry, 2 pi because we're in radians. But you want a common denominator, so 3 over 3. It's 3. 6 pi over 3, so I get 5 pi over 3. And then if you want a negative coterminal angle, we're just going to subtract 2 pi. So common denominator. So I get negative 7 pi over 3. And those are coterminal angles. Ooh, we're doing some more sketching the reference angle. So more practice on this. This will become very helpful in a later lesson. This is why I spent so much time on this. Negative 1 time will go faster. 0, negative 90, negative 180, negative 120 between these two. So around there somewhere is negative 120. So I have to sketch it, then find the reference angle. I had to do that earlier. And I just didn't. My mistake. So 180 and 120 is 60 degrees apart. So that's my reference angle. 350. I swear we did this one already. 0, 90. This is all different when I had to do it. 180, 270, 360. So 350 is between these two. So it'll be over here somewhere. 350. Which makes a reference angle. Again, reference angle is the small side of the acute angle. So that's 10. It's 10 degrees away. 510. Oh, we definitely did this one. So I'm going to use coterminal angle this time. We're going to subtract 360 from it. So I'm going to get 150. So the exact same thing is 150. So I'm just going to graph 150. So here's 0, here's 180, here's 90, 150 being here somewhere. And then that's my angle. It makes this the reference angle. Between 150 and 180 is 30 degrees. Radian measure. Now again, these are easy to find the reference angle. I have the answer already. This is 45. It's over 4 automatically. Over 6 is automatically 30. Over 3 is automatically 60. So really easy to find the reference angle. But I do want you to draw it. So this is 0, this is pi, and the trick is to use common denominators. So you're going to want to make this 4 over 4. So 5 pi over 4 will be just a little past this. So it'll be over here somewhere. And then that'll be your angle. I do that way too much. 11 pi over 6, same idea. So here's 0, here's pi. Make that 6 over 6. There's a problem though, that's 6 over 6. Right, 1 less, 5 pi over 6. 1 more, a little past, that'd be 7 pi over 6. By the way, what's over here? 1 pi over 6, right? Quadrant 1 is always the first one. 1 pi over 4. 1 pi over 6. I gotta get the 11, so what you do is you go around again. So 6 over 6, another 6 over 6. 6 over 6 plus 6 over 6 would equal 12 pi over 6. By the way, 12 pi over 6, same thing as 2 pi. That's why that's this. So that's 12 pi over 6. So we're a little short of that. We haven't got there yet, so we're in this quadrant. 11 pi over 6 is over here. So this is the angle we made, and my reference angle right here would be, it's 60, so it's over 6, so it's automatically 30 degrees. Pi over 3, remember from the first time we did it, here's 0, here's pi over 2. Anytime it's over 1, it's in the first quadrant. So pi over 3, and that angle would be 60 degrees because it's over 3. Next one. The skateboard ramp at the right is called a quarter pipe. There we go, there's my quarter pipe. The curved surface is determined by the radius of the circle. Find the length of the curved part of the ramp. So they want me to find this part. The quarter pipe right there. So, that's our arc length. How do we find arc length? L equals r times theta. Do I have all this stuff? Oh, I have r. R is 8. Do I have theta? Now I have 90 degrees, but don't remember what? This only works in radians. So I gotta convert 90 degrees to radians. Now you could kind of already know it from the picture. 90 degrees is up here. What is up there for radians? Pi over 2. But just to show you, I'll convert it using the formula. And I get 90 pi over 180. If you reduce that, you get pi over 2. So 8 times pi over 2. I get 8 pi over 2, also known as 4 pi. So that's the length of the curved part, is 4 pi. Now mine's a little different because it's all curly, but that was the idea. The paddle wheel of a riverboat has a diameter of 24 feet. Find the arc length of the circle made when the paddle wheel rotates 300 degrees. So let's draw it. Let's see. There's my wheel. So a paddle boat. So that's like the end of a big. That's like what powers a big old, what's it called? A riverboat. Let's draw this. There's my riverboat. And that's the paddle wheel. It has like the spokes here, blah, 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 blah. Kind of like that. You get the gist. Diameter is 24 feet. So the diameter of this guy is 24 feet. It rotates 300 degrees. Okay, so we know that. I want to find the circle. Let's find the arc length of the circle made. So arc length, as we talked about, L equals r theta. I just need two things. I need the L, which I started the R. That's what I'm looking for, the L, which is the radius. I need the theta, but in radians. Right. So we have a couple problems here. I have the diameter. I need the radius. So that's 24 feet. This must be only 12 feet. Boom. And then the angle is in 300 degrees. I need radians, so we can convert it. 300 times pi over 180. So I get 300 pi over 18. Now this is a application problem, so you don't need to worry about reducing because I'm just plug in my calculator anyway to get the answer. I could reduce it, divide by 0, then cancel out the zeros, you cancel out the 6s. Divide by 6 to reduce it, but it's going to go my calculator anyway, so work smarter, not harder. Uncle Scrooge reference for you guys. And he actually made some money on the riverboat based on the original DuckTales series. So it all comes together. Love that series. Anyway, so we get 62.8. That's the length of the arc. That's the length of the arc made by the circle, made by the paddle wheel. Let's see the next one. The Wonder Ferris wheel at Coney Island has a radius of 68 feet. At least it gave us a radius this time. It is 15 feet off the ground. Okay. Another person gets on the bottom of the car. The Ferris wheel rotates 202 degrees clockwise before stopping. How high above the ground is the car when it happened? Ooh, when it stops. So this is probably the most advanced question we had on here today. So let's look at this one. So you start down here, 15 feet above the ground, and then you go up around this way because we're going clockwise, about 202 degrees. It says it stops there. So how am I going to do this? Well, so I know it's 15. I got to figure out how much all of this is. All of that is. So a radius is 60. The radius is 68 feet, right? So from here to here, 68. But I need to figure out how the height of A is, because this is still 68. But what is like 8? What's this? I'm looking for this guy. So what we're gonna do is figure out what this angle is, then multiply the ratio of the arc that we've gone down. So it's gonna be kind of like this. It'll make more sense when you see me do it. So we got that angle is 202.5. I always want to figure out what this angle is, right? So all this is 202.5. Let's subtract off this half circle I don't want. So minus 180. And I get 22.5. Now I want to figure out what portion of this have we gone down. So we're going to go 22.5 over 360 and multiply that by how tall is our radius, 68. Multiply that together, you get about 4.25. So what is that 4.25? Now 4.25 is, we figured out is this guy. From here to here. That's how much it went down, 4.25. It went down 4.25 from the start because it's gone 22 degrees this way, so it's gone down about 4.25. Why did I put a degree sign there for? It makes no sense. There I go. So that's how much it's gone down. So it's gone down about 4.25 feet. So we got to figure out what the rest of this is, though. We got to figure out what this guy is. Well, if the whole radius is 68, let's subtract that from 4.25. If you do that, you get 63.75. So that's what this is, 63.75. We have the half of this. We have that the bottom part radius of the Ferris wheel, which is 68. Then we have a little bit of the height above the ground, which is 15. Right, it's 15 feet off the ground. You add all those together, plus 68 plus 15, and when you add them all up, you get about 145.8 feet. There's that answer. Again, that was a weird one. Next one's more jam. A sinker rotating back and forth shoots water at a distance of 10 feet. So you see 10 feet in either direction. From the horizontal position, it rotates 145 degrees. So it goes from here to here, so 145 degrees. Before reversing its direction, so it goes 145, stops, goes 145, stops, 145. At a 145 degree angle, how far to the left the sprinklers of water reach? So like how many feet does this go across? So just trying to find the arc length again. That's all they want you to find, the arc length of this guy. So equals r theta. Remember, r they give to us already is 10 feet. And then theta has to be in radians. So they gave us 145. You got to convert that to radians. You multiply by pi over 180. And you get 145 pi over 180. Again, if I want, I can reduce this. But it's an application problem. I'm going to put in our calculator anyway, so it doesn't really matter. So I'm going to get 10 times 145 pi over 180, which equals, use our calculator. There you go. 145 pi divided by 180 times 10. And I get about 25.3 feet. So it reaches 25.3 feet that way. There you go.